Question number 9. In a parallelogram ABCD, 2 points P and Q are taken on diagonal BD such that DP equal to BQ. See figure 8.20. Then show that first one, triangle APD congruent triangle CQB. Second one, AP equal to CQ. Third one, triangle AQB congruent triangle CPD. Fourth one, AQ equal to CP. Last, fifth one, APCQ is a parallelogram. It's a bigger question. We have to prove 5 parts are there to prove. Okay. Given that ABCD is a parallelogram, that is the first part. ABCD is a parallelogram. This figure is given. Okay, ABCD. So I'm going to draw that figure. This is figure given. ABCD. A, B, C, D is a parallelogram. BD joints. And PQ on Q here. P here, equal distance. Join AQ okay. So this is a figure given. What are given in the question? P and Q are taken on diagonal BD such that DP equal to BQ. DP, this side DP equal to BQ. These smaller two sides are equal. Given ABCD is a parallelogram. We know that in a parallelogram, opposite sides are equal and parallel. So, AB, CD equal and BC, AD equal. And given that this BQ and PD are equal. Then, this is given in the question, BQ equal to PD, DP. DP equal to BQ. This is also given. Okay. So, these are the given parts. So, first one we have to prove triangle APD congruent triangle CQB. Triangle APD. Which is triangle APD? This is triangle APD. This is small triangle. Triangle BQ, CQB. This is triangle CQB. Consider these two triangles. Smaller triangles. APD. These two. In these triangles, we can say that here given DP and BQ are equal. That is given. DP equal to BQ and DA equal to BC. Okay. DA, BC, that is opposite sides of parallelogram ABCD, they are equal. Now one more to get. We can take these two angles. Let it be 1 and 2. Angle 1, angle 2. What type of angles are there? This 1 and 2. These are alternate interior angles. So they are equal because it's a parallelogram. AD parallel BC. So when these two sides are parallel and BD becomes transversal, then angle 1 equal to angle 2 by alternate interior angles theorem. Now we have two pairs of sides equal and include angle equal, then the triangles are congruent by SAS congruency. Okay, so consider those triangles. In triangle APD, and triangle CQB. First part, DP equal to BQ. That is given in the question. Okay, then DA equal to BC. They become equal because they are the opposite sides of parallelogram. Reason opposite sides of parallelogram. Okay, opposite sides of parallelogram are equal. We know that. So just write opposite sides of parallelogram. That's enough. Third, angle 1 equal to, right, angle 1 equal to angle 2. Reason alternate interior angles. They are alternate interior angles. Now we have 3 parts are equal, 2 sides and include angle. So which implies triangle APD congruent triangle CQB. SAS congruency. Okay. So first answer completed. Answer 1 completed. APD congruent CQB. Second one, AP equal to CQ. We know that in triangle APD, CQB, they are the corresponding parts. See this triangle APD, congruent triangle CQB, so they are equal. Okay. Then this is second answer. Then AP equal to CQ. Reason CP, CT. So two answers completed. APD, in APD, AP. Okay. In CQB, same marking, 4 lines. Okay. Because many sizes are there, that's why I use this to find the equal size. AP equal to C. So second answer completed. Now third one. AQB congruent CPD. Consider third one. Triangle AQB. Which is triangle AQB? This is triangle AQB. Okay. This, the other one, this one. Okay. Triangles having tick mark. Triangle AQB. AQB. Second triangle CPD. CPD. So to be congruent, what are equal there? What are equal in those triangles? We know that BC and CD are equal because they are opposite sides of parallelogram. Then also BQ and DP are equal. BQ and DP are equal. That is given. Now one more to get. So which is that one to get? We know that CD parallel AB because it's a parallelogram. So this angle, it will be 3. And this angle 4, and this angle 3 and angle 4 are equal. Correct? Angle 3 and angle 4 are equal, alternate interior angles. Okay, so triangles are congruent by SAS congruency. So consider triangle AQB in triangle AQB and triangle CPD. Okay, first use this one. BQ equal to DP. That is given. Okay, so BQ DP used. Then AB equal to CD. AB equal to CD. Reason opposite sides of parallelogram. So second order. Then third, angle 3 equal to angle 4. Angle 3 equal to angle 4. Reason alternate interior angles are equal because it's a parallelogram. Okay, opposites are parallel, which implies. So now we have two pairs of sides equal and one included angle equal. Then triangle AQB congruent triangle CPD. This SAS congruency. SAS congruency. Okay, so answer 3 completed. So answer from answer C. Next answer 4. AQCP. AQ side of AQB, CP side of this one. Then this is fourth one. AQ equal to CP. These two sides. Okay. CP, CT. CP, CT. So that is completed. Answer 4 completed. Now we have to prove here from this we got AQ equal to CP. Or say AQ and CP. So this is AQ. Now we have AQ and CP are equal. Okay. So last one, to prove the last one. APCQ is a parallelogram. That is the last one. APCQ is a parallelogram. So to be a parallelogram, either opposite sides are parallel equal or one pair of opposite sides parallel or each pair opposite angles equal. Then let us check APCQ. APC, this is a smaller quadrilateral here, APCQ. This is a quadrilateral. Okay. This figure. So to be parallelogram. You can check APCQ and whether it become a parallelogram or not. Here we know that AP equal to CQ. We proved. Okay, already we proved. So that's why in quadrilateral, now it is a quadrilateral. APCQ, AP equal to CQ. Just to prove. We proved that. Okay. And these are also equal. AQ equal to CP. That is also proved. And AQ equal to CP. Proved. Now we have opposite sides are equal. When opposite sides are equal, which implies the figure is a parallelogram. Which implies AP APCQ is a parallelogram. Okay, so answer for completed. Now, question number 10. ABCD is a parallelogram and AP and CQ are perpendiculars from vertices A and C on diagonal BD. Given ABCD is a parallelogram. A parallelogram given. That is ABCD. ABCD is a parallelogram. AP and CQ are perpendicular from A and C on diagonal BD. So join diagonal BD. So draw perpendiculars to BD. Two perpendiculars from A and C. Okay, which are perpendiculars? AP, CQ. AP, CQ. Okay, perpendiculars. First one, to prove triangle APB congruent triangle CQD. Triangle APB. Which are triangles APB and CQD. This is triangle APB, triangle CQD. So first to prove these two triangles are congruent. It's very easy to prove because we know that in a parallelogram opposite sides are parallel and equal. So these two pairs AB equal to CD, AD equal to CD. Okay. Now consider these two triangles only. Triangle APB, triangle CQD. We know that in APB CQD, AB equal to CD because opposite sides of parallelogram are equal. And second one, this angle CQD equal to angle APD 90 degree each. Also we can say that these angles are equal. Okay, these two angles are equal. This angle represents triangle APB, this angle represents triangle CQD. These two angles are related to angle 1, angle 2. Okay, angle 1 equal to angle 2. What type of angles are there? They are alternate interior angles because ABCD is a parallelogram. Now we have two angles equal and one side, and the side is not included because side we use the AB and CD and the angles on DQ. This angle Q and angle D. Okay, so this represents AAS congruency to get the triangles congruent. So let's start with triangle APB and triangle CQD. Given the left side given ABCD is a parallelogram. Okay, in ABCD is a parallelogram. So which implies AB equal to CD and BC equal to DA. Now let's consider in triangle APB and triangle CQD. First AB equal to CD. AB equal to CD. Reason opposite sides of parallelogram. Second, and consider angles. Angle APB equal to angle CQD. Because AP perpendicular BD, CQ perpendicular BD, then we can say that each angle is equal to 90 degree. Angle APB equal to angle CQD. 90 degree. Reason altitudes. No. By perpendiculars. Reason. By perpendiculars. Okay. Now one more to get. Angle 1 equal to angle 2. Reason alternate interior angles because of parallelogram. Okay. Which implies now two angles and one side. Here clear that here side is not included. So we have to use AAS congruency, which implies triangle APB congruent triangle CQD by AAS congruency. Okay, so first answer completed. Second one, AP equal to CQ. Here AP, CQ. Or what are AP and CQ? They are corresponding sides. Then, so second answer completed. AP equal to CQ. CP, CT. So answer number 10 completed. So next question number 11. In triangle ABC and triangle DEF, AB equal to DE, AB parallel DE, BC equal to EF, and BC parallel EF. Vertices A, B, and C are joined to vertices D, E, and F respectively. See figure. As first one, quadrilateral ABED is a parallelogram. First to prove ABED is a parallelogram. Second to prove BEFC is a parallelogram. Third one, AB parallel CF and AD equal to CF. Fourth one, quadrilateral ACFD is a parallelogram. Fifth one, AC equal to DF. Sixth one, triangle ABC congruent triangle DEF. So given to triangle ABC and triangle DEF given. This is a given figure. First one to prove ABED is a parallelogram. So what is given? Given AB equal to DE and AB parallel DE. Second, BC equal to EF and BC parallel EF. Okay. Now, first one to prove quadrilateral ABED is a parallelogram. ABED, which is ABED. This is ABED. Consider this. Here, in quadrilateral ABED, we know that it is given that AB equal to DE. That is given in the question. AB and DE are equal. Also, AB parallel DE. Okay. In a quadrilateral, when one pair of sides parallel and equal, then it is said to be a parallelogram. The starting property. Okay. Now, so start with that. In quadrilateral ABED. In quadrilateral ABED, here AB equal to DE and AB parallel DE. One pair of sides parallel and equal. AB, DE equal given here. AB parallel DE, that is also given. One pair of sides parallel and equal, then the quadrilateral becomes a parallelogram. Which implies ABED is a parallelogram. Okay, this is required. No need of proving that, just use that property. By the property. Okay, by theorem. Now, first answer completed. Answer 2. Quadrilateral BEFC is a parallelogram. Quadrilateral BEFC. Now we have ABED is a parallelogram. So when ABED is a parallelogram, then we can say that BE and AD are equal. So which implies, let's write that, because that will be required. BE equal to BA. Opposite sides of parallelogram. Okay. Now consider second quadrilateral BEFC. BEFC. These two this quadrilateral BEFC. Here also BC equal to EF and BC parallel EF. That is given. Second batch. Opposite sides are parallel. One pair of opposites parallel and equal. Then it also becomes a parallelogram. That's second. In quadrilateral BEFC, which are equal, BC equal to EF and BC parallel EF. Okay. Then by theorem 8.8 implies this BEFC is a parallelogram. Okay, now BEFC becomes a second answer completed. So when BEFC is a parallelogram, then we can say that BE equal to FC. Then these sides are also equal. Okay, here first we proved this equal. Now we have BE equal to FC. Then BE equal to FC. Reason opposite sides of parallelogram. Okay, so first two over. Next, AD parallel CF and AD equal to CF. AD parallel CF and AD equal to CF. Here, from the first parallelogram, we got BE equal to DA. We just wrote BE equal to DA, write this more. BE equal to DA and BE parallel DA, because it becomes a parallelogram. In a parallelogram, opposite sides are equal parallel. So right here, this also, just right here, and BE parallel DA. Okay, reason same opposite sides of parallelogram. That will be equation number 1. Here and BE parallel FC. Okay, reason the same. Let it be equation number 2. Well, we know that in a parallelogram, opposite sides are equal and parallel. So consider these steps to prove the third one. So from this 1 and 2, from 1 we have DE equal to DA. Here BE equal to FC. That means DA and FC are equal. So that is third one. AD equal to CF. CF means FC. Okay, and AD means DA. Also BE parallel DA. BE parallel FC. So DA parallel FC. Now from 1 and 2, from equation 1 and 2, we get, what is to prove here? AD. We wrote here DA parallel FC and DA equal to FC. Okay, which implies DA becomes AD parallel CF and AD equal to CF. Okay, I just change the name. Okay, DA becomes AD, FC becomes CF, DA, AD, FC. Okay, now answer 3 completed. Next answer for quadrilateral, okay, ACFD. Quadrilateral ACFD is a parallelogram. Quadrilateral ACFD is a parallelogram. Quadrilateral AC, which is ACFD. ACFD. Okay. Here now we have in this figure, in quadrilateral ACFD, we have this CF parallel AD and CF equal to AD, just wrote here. Okay. AD parallel CF and AD equal to CF, then it becomes a parallelogram. Now in quadrilateral ACFD, AD parallel CF and AD equal to CF. Both proved. Reason proved. Which implies when one pair of parallel sides are equal and parallel, then which implies ACFD is a parallelogram. So that answer also completed. Answer 4 completed from theorem 8.8. Then AC equal to DF. AC equal to DF. Then now we have ACFD is a parallelogram. So in a parallelogram, opposite sides are equal. Now these two sides are equal. Then AC equal to DF. Reason opposite sides of parallelogram. Okay, these two sides becomes equal. Now last one, triangle ABC congruent triangle DEF. So consider triangle ABC and triangle DEF. In triangle ABC and triangle DEF, already we have in triangle ABC and DEF, already we have AB equal to DE. AB equal to DE, that is given in the question. Okay, given. Second part, BC equal to EF, that is also given. Second part, BC equal to EF, given. Now one more to get. Okay, consider these triangles. Here AB equal to DE, that is given. BC equal to EF, given. Now we proved AC and DF are equal. If AC equal to DF, we just proved. And AC equal to DF. AC equal to DF. Now in triangle ABC and triangle DEF, 3 sides are equal. Okay, when 3 pairs of sides are equal, then the triangles are congruent. Then which implies triangle ABC congruent triangle DEF. Reason SSS congruence rule. Okay, so that question completed. Question number 11 completed. One more question is there. Write that question as homework. So we have completed exercise 8.1. 12 questions completed. Next, let us go through the second part of this lesson, midpoint theorem. Next, the new theorem is midpoint theorem. So what is midpoint theorem? The midpoint theorem. What is midpoint theorem? The line segment joining the midpoints of any two sides of a triangle is parallel to the third side. And also, we can say that that line segment is half of the third side. Okay, the theorem is the line segment joining the midpoints of two sides of a triangle is parallel to the third side and half of it. Okay, write that also. Okay, that is not given in the textbook, but it is also, we can prove that. Okay, let's prove this theorem, but no need of studying that proof. That is not an important one. Just motivation is enough. So study the theorem or property very well. Okay, its property and its converse is also there. Its converse is the line drawn through the midpoint of one side of a triangle parallel to another side by its third side. That is converse. So let us start with the original theorem. The line segment joining the midpoints of two sides of a triangle. Let triangle ABC. Consider the midpoints of AB and AC. Let midpoint of AB be E and midpoint of AC F. Now join this. The line segment joining midpoint, that is EF. Okay. Here the line segment join the midpoint. This is given. E and F are the midpoints of the sides AB and AC of triangle ABC. Now what is to prove? That is parallel to the third side. That is to prove. That means we have to prove that EF parallel BC. EF parallel BC. That is to prove. So how to prove EF parallel BC? So let us produce this EF. Produce this EF in such a way that EF equal to DF. And take another point D. Okay. Join CD. Now we have EF and DF are equal. Okay. Now consider these two triangles. Here we produced EF to D such that EF equal to DF. Now we have EF equal to DF. EF equal to DF. EF equal to DF. Second one, AF equal to CF. AF equal to CF. Why? Because F is the midpoint of AC that is given. Okay. Now one more. These two angles are equal. These two angles are equal. Angle AFE equal to angle CFD. Result, vertically opposite angles. Okay. Now we have two sides and one included angle. Two sides and included angle are equal in two triangles. Then we can say that the triangles are congruent. Then which implies triangle AFE congruent triangle CFD by SAS congruency. Okay. Then when two triangles are congruent, then we can say that all the other parts are equal. Then we can say that this angle 1 and angle 2 equal, then which implies angle 1 equal to angle 2. Okay, CPCT. Also AE equal to this CD. AE equal to CD. Again CPCT. Okay, these are okay, enough. Now, what type of angles are 1 and 2? They are alternate interior angles. 1 and 2 are alternate interior angles. Then we can say that angle 1 equal to angle 2. Here we have angle 1 equal to angle 2, which implies AB parallel DC. AB parallel DC. When alternate interior angles are equal, on transversal AC. Okay. Then the sides are parallel. Which are sides? AB and CD. AB parallel DC. Okay. AB parallel CD. or DC. Parallel. Okay. By converse of alternate interior angles property. Now we have these two sides are parallel. So when AB parallel DC, we can say that EB also parallel to DC. Change AB into EB. Okay, because EB is part of AB. EB parallel to DC. EB parallel to DC. Okay, let it be first statement. Okay. Also we have this AE equal to DC. AE equal to DC we got here from here AE equal to DC. Also we have AE equal to BE. Here we have AE is also equal to BE. AE also equal to BE. Why? Because E is a midpoint, that is given. When E is a midpoint, AE and BE are equal. So these three sides are equal. Okay. AE DC equal, AE BE equal. So BE equal to DC. So from these two we can say that BE equal to DC. Okay. From these two. Because AE is common, so CD and BE are equal. It will be number 2. So now consider 1 and 2. In 1, EB means BE. Okay, EB and BE are same. These are same. EB, BE both are same. EB parallel DC. Here EB equal to DC. Okay, this is EB and BE are same. And with the DC parallel and with the DC equal, same pair of opposite sides parallel and equal, then the quadrilateral becomes a parallelogram. Now we have in this figure, it's a quadrilateral. B, C, D, E is a quadrilateral now. But in this quadrilateral now we got this BE and CD are equal and parallel. One pair of opposite sides parallel and equal, which implies the figure B, C, D, E is a parallelogram. Okay. Now the figure becomes a parallelogram. And in a parallelogram, what are the properties of a parallelogram? The first two properties. Opposite sides are equal, opposite sides are parallel. In a parallelogram, opposite sides are parallel. Consider that one, opposite side. Already we have BE parallel CD. Okay. And BE equal to CD. It changes the figure into a parallelogram. Then we have ED parallel BC, which implies ED parallel BC. Okay. ED parallel BC. Opposite sides of this parallelogram. Then change this. When ED parallel BC, we can say that EF parallel BC because EF is a part of ED, which implies EF parallel BC. So hence prove EF parallel BC. So what are E and F? E and F are the midpoints of two sides of triangle, and the line segment joining the midpoints is parallel to third side. Proved. Okay. So theorem 1 completed. The second part of that one, that is not given in the textbook, but study that one also. It is EF equal to half BC. EF will be equal to half BC and half of it. That means EF is, to prove EF is parallel to BC, also EF equal to half BC. Okay, so how to prove that? We know that ED equal to BC. We know that ED equal to BC. So we can say that ED is 2EF. ED can be written as 2EF because EF and DF are equal. Okay, by construction, we consider EF and DF equal. So then we can say that ED is 2EF or 2DF. So consider here 2EF. Then ED becomes 2EF equal to BC, which implies EF equal to BC by 2. That is, what is BC by 2? Half BC. Okay, so EF is half BC. So that is the property. Okay, completed.